A perfect mattress feels like a cloud, a warm embrace, or even a soft cake. But have you ever wondered how these luxurious beds are actually made? Today, we take you inside high-tech Korean mattress factory. Raw materials are transformed into the ultimate sleep experience, precisely engineered for comfort, durability, and that signature plushness. From precision-cut memory foam to highly engineered spring systems, every mattress goes through a meticulous production process before it reaches a customer's home. Some mattresses are designed to be ultra-soft, while others are built for firm support. But no matter the type, they all undergo a series of carefully controlled steps to ensure quality and longevity. Join us on this journey as we uncover the secrets behind mattress manufacturing, revealing why Korean factories have perfected this process. Before we begin, make sure to like this video and subscribe to the channel if you enjoy exploring how everyday products are made. Selecting the materials. A high-quality mattress starts with a selection of premium materials, each chosen to enhance comfort, durability, breathability, and support. Korean manufacturers have mastered the art of combining advanced materials that cater to various sleep preferences. Whether someone prefers a firm mattress for back support or a plush one that cradles the body, the materials used in mattress construction must meet strict industry standards to ensure they provide proper spinal alignment, motion isolation, and temperature regulation. Let's take a closer look at the key components that go into making a top-tier mattress. Memory foam. Personalized contouring for pressure relief. Memory foam is one of the most revolutionary advancements in mattress technology. Originally developed by NASA in the 1960s for cushioning astronauts during space travel, this material has become a staple in the mattress industry due to its ability to conform to the sleeper's body. Adaptive comfort. When someone lies down, the memory foam responds to body heat and pressure, molding to their unique shape. This provides optimal support and even weight distribution, reducing stress on pressure points like the shoulders, hips, and lower back. Motion isolation. One of the major benefits of memory foam is that it absorbs movement. If a person tosses and turns at night, their partner is far less likely to feel the movement, making it an excellent choice for couples. High-density foam layers. Premium mattresses use multiple layers of memory foam, each with different densities to create a balance of softness and support. Lower density foams allow for a plush feel, while higher density foams provide long-lasting durability. Latex foam. Natural resilience and breathability. Latex foam is a high-end material known for its bounce, durability, and breathability. Unlike memory foam, which slowly conforms to the body, latex provides instant responsiveness, giving the sleeper a feeling of weightlessness. Natural versus synthetic latex. Natural latex is derived from rubber tree sap, making it an eco-friendly and hypoallergenic option. Synthetic latex, while more affordable, may not offer the same level of durability. Temperature regulation. Unlike traditional memory foam, latex does not retain heat. The open cell structure promotes excellent airflow, keeping sleepers cool throughout the night. Longevity. Latex mattresses are among the most durable on the market, lasting up to 15 years or more with proper care. Polyurethane foam, the essential support layer. Polyurethane, PU foam, is another critical component in modern mattresses. While it lacks the contouring ability of memory foam, it plays a crucial role in providing a stable foundation for the mattress. Base support. High-density polyurethane foam is commonly used as the bottom layer of hybrid and memory foam mattresses to prevent excessive sinking. Soft versus firm varieties. PU foam can be manufactured in different densities, allowing manufacturers to customize mattresses for different sleep preferences. Pocket coil springs, the backbone of hybrid mattresses. Spring systems have evolved over the years, and today's pocketed coil technology provides unmatched support and motion control. Unlike traditional innerspring mattresses where coils are interconnected, pocket coils are individually wrapped in fabric sleeves, allowing them to move independently. Pressure relieving zones. Advanced designs incorporate softer coils in pressure-sensitive areas, such as the shoulders and hips, while using firmer coils in the lumbar region to provide targeted support. Edge support reinforcement. High-quality mattresses reinforce the perimeter of the mattress with sturdier coils, preventing sagging and allowing for full use of the bed's surface. Cooling gel layers. Advanced temperature regulation. One of the biggest complaints about foam mattresses is heat retention. To combat this, manufacturers infuse cooling gel particles into the foam. Heat dissipation. The gel works by absorbing excess heat and distributing it away from the sleeper, ensuring a cooler sleeping surface. Gel bead versus phase change material, PCM. Some high-end mattresses go beyond gel beads and incorporate PCM technology, which actively adjusts to body temperature in real time. Breathable fabric covers, the first layer of comfort. The outermost layer of a mattress is just as important as its internal components. Korean factories use advanced fabric blends to create covers that are soft, breathable, and durable. Moisture wicking technology. Some covers are made from materials like bamboo or tencel, which naturally wick away moisture, keeping the mattress dry and fresh. Antimicrobial treatments. High-quality covers are often treated with antibacterial coatings to prevent dust mites, mold, and allergens from accumulating over time. Before these materials are used in mattress production, they undergo rigorous quality control tests to ensure longevity, comfort, and safety. Cutting and shaping the foam. Once the materials are selected, the next step is precision cutting to form the mattress layers. This step requires advanced machinery to ensure each layer meets exact thickness specifications for comfort and durability. Automated cutting machines. Precision at high speed. Large foam blocks are stored in temperature-controlled rooms to maintain consistency before being transported to the cutting area. Computer-controlled cutting blades. These high-speed machines slice foam into various thicknesses with millimeter-level precision. Customizable designs. Some manufacturers create specific foam shapes to enhance comfort, such as wave-like patterns that provide additional lumbar support. Profile cutting. Enhancing comfort and airflow. Instead of using flat foam layers, some mattresses incorporate textured surfaces to improve breathability. Air channels for cooling. Strategically placed grooves and perforations allow heat to escape, keeping the mattress from trapping warmth. Zoned support designs. Some mattresses use multi-layered foams with different firmness zones to promote better spinal alignment. Gel infusion process. Adding a cooling element. If the mattress features gel-infused memory foam, this step involves carefully mixing and injecting liquid cooling gel into the foam structure before it sets. Even distribution. The gel is evenly spread to ensure uniform cooling properties across the entire mattress surface. Durability testing. The foam is tested to make sure the gel does not break down over time. After the foam is cut and treated, it is carefully inspected before moving to the next phase of mattress assembly. Spring coil. Manufacturing. For hybrid mattresses that combine foam with springs, the next step involves crafting the perfect spring support system. Coil formation. High tensile steel wires are fed into advanced machines that twist and shape them into individual coils. These coils are then tempered at high temperatures to increase strength and flexibility. Pocketed spring encapsulation. Unlike traditional spring mattresses, modern designs feature individually wrapped coils that move independently. Each coil is encased in a fabric sleeve to prevent noise and minimize motion transfer. Zoning technology. To provide optimal support, manufacturers create mattresses with different firmness levels across various sections. Softer coils are placed in areas that need more cushioning, while firmer coils support heavier parts of the body. Compression testing. Before being integrated into the mattress, the coil system undergoes rigorous stress testing to ensure it can withstand years of use without losing its structural integrity. Once the springs are complete, they are ready to be combined with the foam layers. Layering and assembly. Now that all the components are prepared, the mattress begins to take shape. Layer by layer construction. The different foam layers and spring systems are stacked together according to the mattress design. The placement of each layer is carefully calibrated to ensure the right balance of softness and support. Adhesive bonding. Specialized adhesives are used to secure each layer while maintaining breathability and flexibility. Some factories use heat sealing techniques instead of glue to create a more environmentally friendly product. Pressure testing. A robotic press simulates years of sleeping by applying force repeatedly to different parts of the mattress. This helps ensure durability and comfort over time. After assembly, the mattress begins to resemble its final form. Stitching and cover design. The outer cover of a mattress is just as important as the internal structure. Korean factories use high-precision quilting machines to create soft yet durable fabric covers. Fabric selection. Premium mattresses use breathable, moisture-wicking materials that stay cool and comfortable throughout the night. Quilting process. The top layer is quilted with intricate stitching patterns that add texture and improve airflow. Antimicrobial treatment. Some covers are treated with hypoallergenic and antibacterial solutions to prevent dust mites and bacteria buildup. Once complete, the fabric cover is stretched over the mattress and secured with reinforced stitching. Packaging and shipping. Before leaving the factory, mattresses go through a final series of quality checks. Vacuum compression. To make shipping easier, the mattress is placed in a vacuum sealing chamber, where it is compressed to a fraction of its original size. Roll packing technology. The compressed mattress is tightly rolled into a compact shape and inserted into a sturdy box for easy transportation. Protective wrapping. A layer of durable plastic is applied to prevent moisture damage during transit. Once packaged, the mattresses are sent to warehouses and retail stores, ready to be delivered to customers. And that is how Korean bed factories transform raw materials into high-quality mattresses that provide comfort and support for years to come. Which part of the process surprised you the most? Let us know in the comments below. It all began in 1886 when Atlanta-based pharmacist John Stith Pemberton created a unique caramel-colored syrup, initially sold in local drugstores as a medicinal tonic. Mixed with carbonated water, it was originally marketed as a remedy for headaches and fatigue. Little did he know that his creation would become one of the most recognized brands on the planet. By the early 1900s, businessman Asa Candler acquired the formula and rapidly expanded the brand. Coca-Cola's iconic contoured bottle was introduced in 1915, ensuring that consumers could recognize the drink even in the dark. Over the decades, Coca-Cola has expanded its product lineup, introduced innovative marketing campaigns, and built a massive network of bottling plants worldwide. With its signature red and white branding, Coca-Cola has become synonymous with refreshment, nostalgia, and global culture. Today, Coca-Cola is more than just a beverage. It's a symbol of American culture and a dominant force in the soft drink industry. Available in over 200 countries and recognized by 94% of the world's population. One of the biggest mysteries surrounding Coca-Cola is its secret formula. Locked away in a high-security vault at the Coca-Cola headquarters in Atlanta, the exact recipe is known only to a handful of people. While the main ingredients include carbonated water, sugar, caramel color, phosphoric acid, natural flavors, and caffeine, the precise blend of these components remains one of the most well-guarded secrets in the food industry. Some believe that Coca-Cola's formula contains a unique blend of spices and citrus oils that give the beverage its distinctive taste. Over the years, rumors have spread about the use of exotic ingredients, with some even speculating about a mysterious ingredient known as Merchandise 7X. While Coca-Cola denies any drastic changes to the formula, some variations exist depending on local ingredient sourcing and regional preferences. The secrecy surrounding the formula has fueled speculation and intrigue for over a century. Stories have emerged about how the company ensures that no single person knows the entire recipe. Instead, different individuals only know partial elements, preventing the formula from being leaked or replicated. This level of secrecy adds to Coca-Cola's mystique, making it one of the most protected trade secrets in the world. The foundation of every bottle of Coke is water, and to ensure consistency across the globe, Coca-Cola employs an advanced multi-step water purification process. Water passes through filtration, reverse osmosis, and UV light treatment to eliminate any impurities before being used in production. This ensures that whether you're drinking Coca-Cola in New York, London, or Tokyo, the taste remains identical. The purification process is so rigorous that Coca-Cola's water quality often exceeds that of municipal drinking water. The company ensures that every bottle starts with a neutral and clean water base before moving to the next step. This guarantees that the flavor remains consistent worldwide, regardless of the local water supply. Once purified, the water is blended with sweeteners. Depending on the region, Coca-Cola is sweetened with either high-fructose corn syrup or cane sugar. Large tanks mix these sweeteners to create a base syrup, which is later infused with the signature Coca-Cola concentrate. Interestingly, in some countries like Mexico, Coca-Cola is still made with pure cane sugar, which many people claim gives it a different and more authentic taste. This variation has led to the popularity of Mexican Coke in other parts of the world, often sold at a premium price. Some dedicated fans even conduct taste tests to compare different versions, fueling ongoing debates about which formulation is superior. Now comes the most fascinating part, the legendary Coca-Cola syrup. This top-secret mixture is produced in a secured area of the factory, with only a select few workers having access. The syrup is carefully blended with the purified water and sweeteners before being transported to the carbonation phase. This syrup concentrate is actually produced in select locations worldwide before being shipped to bottling plants, where it is diluted and carbonated on site. This global approach ensures that every bottle of Coca-Cola maintains the same signature taste, regardless of where it is produced. The syrup is transported in special containers under strict security measures, ensuring that the formula remains protected at all times. If you're fascinated by the incredible technology and precision behind Coca-Cola production, don't forget to hit that like button. And if you love learning about how your favorite products are made, make sure to subscribe for more behind-the-scenes factory tours. Ever wondered what gives Coke its signature fizz? Carbon dioxide is injected into the mixture under high pressure, creating that refreshing burst of bubbles with every sip. The carbonation process is meticulously controlled to ensure every bottle or can has just the right amount of effervescence. If you've ever opened a bottle of Coke and heard that satisfying hiss, you've just experienced the power of precise carbonation. Carbonation does more than just add fizz. It enhances the overall taste experience. The bubbles create a tingling sensation that stimulates the taste buds, making Coca-Cola even more refreshing. The level of carbonation is carefully adjusted depending on the container type, ensuring the perfect balance between fizziness and smoothness. Now that the Coca-Cola mixture is ready, it's time for bottling. The factory uses a highly automated system capable of filling thousands of bottles and cans per minute. Plastic bottles start as small preforms, which are heated and blown into shape. Meanwhile, glass bottles and aluminum cans are sterilized and prepared for filling. As the bottles rush down the production line, high-speed filling machines precisely measure and dispense the Coca-Cola mixture, ensuring each container gets the exact right amount. Once filled, bottles are sealed with caps, while cans receive airtight lids. Labels and expiration dates are printed before the products move to quality control. At this stage, every bottle and can undergoes strict quality control to maintain Coca-Cola's reputation for consistency and safety. Advanced sensors and high-speed cameras meticulously inspect each container for leaks, incorrect fill levels, dents, or any imperfections that could compromise quality. These inspections happen in real time, with the technology capable of detecting even the slightest anomaly. Any defective products are immediately removed from the production line to ensure that only flawless items move forward. But the process doesn't stop there. Before leaving the factory, random samples from each batch are taken to dedicated laboratories where they undergo rigorous testing. This includes taste tests conducted by trained professionals to ensure the flavor profile matches Coca-Cola's iconic taste. Additionally, scientists analyze the chemical composition to verify that it meets the company's strict standards for quality, purity, and freshness. Beyond sensory evaluations, laboratory tests also assess carbonation levels, pH balance, and ingredient ratios to guarantee uniformity in every bottle and can. Even the packaging material is tested for durability to withstand shipping and handling. Only after passing these comprehensive quality checks are the products deemed fit for distribution. Once quality control is complete, the bottles and cans move on to the packaging stage. They are labeled with precise details, including the production date and batch number, to ensure traceability. Sophisticated robotic arms efficiently place the labeled containers into cases, stacking them with remarkable accuracy and speed. These cases are then wrapped and secured on pallets, making them ready for shipping. From massive distribution centers strategically located worldwide, Coca-Cola products are transported via an extensive logistics network. This involves trucks, ships, planes, and even specialized refrigerated containers to maintain freshness during transit. Whether heading to bustling city supermarkets, rural convenience stores, or vending machines in remote areas, the journey is carefully coordinated to minimize delays and maintain product integrity. Coca-Cola's distribution network is a marvel in itself, operating around the clock to ensure that a cold can of Coke is always within reach, no matter where you are in the world. Beyond production, Coca-Cola is continuously innovating its packaging and sustainability efforts. In recent years, the company has invested in eco-friendly initiatives, such as developing 100% recycled PET plastic bottles and reducing water consumption in factories. Their World Without Waste initiative aims to collect and recycle one bottle or can for every one sold by 2030. Additionally, Coca-Cola has been experimenting with biodegradable packaging and investing in renewable energy sources to reduce its carbon footprint. These sustainability efforts reflect the company's commitment to a greener future, while still delivering the same refreshing beverage loved by millions. At the heart of every can is a carefully measured combination of caffeine, taurine, B vitamins, and alpine spring water, a formula that has remained unchanged for decades. The process starts with purified water sourced from alpine springs, ensuring maximum quality and consistency. This water is pumped into massive stainless steel mixing tanks, where it is blended with an exact amount of sugar or sweeteners, depending on whether it's the original or sugar-free variant. To create the drink's energizing effects, synthetic caffeine and taurine are added next. The caffeine provides that familiar mental boost, while taurine, an amino acid found naturally in the human body, supports neurological function. The mix is then fortified with B-group vitamins, which help convert food into energy. After thorough blending, the liquid undergoes a filtration process to remove any impurities and ensure consistency. The mixture is then carbonated, giving Red Bull its signature fizz. Carbon dioxide is injected into the blend under precise conditions, creating that refreshing, lightly sparkling effect that fans love. At this stage, the drink is cooled and transferred to massive holding tanks, ready for canning. Red Bull's sleek aluminum cans arrive at the factory in bulk, stacked in towering pallets. Before filling, each can is thoroughly washed and sterilized to maintain the highest hygiene standards. Then, in an ultra-fast and precise filling line, each can is filled with the carbonated Red Bull mixture in a matter of milliseconds. If you're enjoying this behind-the-scenes look, don't forget to like this video and subscribe for more fascinating factory tours. Once filled, the cans move along a conveyor to be sealed with precision-engineered aluminum lids. This step is crucial in maintaining Red Bull's shelf life and signature taste. The lids are crimped onto the cans using high-speed sealing machines, ensuring an airtight seal. Next comes the branding process. Each sealed can passes through a labeling station where the instantly recognizable blue and silver design is printed onto the surface. This step happens at an astonishing rate, with thousands of cans processed per minute. Now it's time for quality control. Every single Red Bull can is checked for imperfections, ensuring it meets the brand's strict global standards. Cans are weighed, pressure tested, and visually inspected to ensure they are filled correctly and free of defects. But production doesn't stop at just making the drink. Red Bull factories are built with sustainability in mind. The company has taken significant steps to reduce its carbon footprint by using energy-efficient machinery, optimizing water usage, and implementing eco-friendly packaging methods. In fact, Red Bull's aluminum cans are 100% recyclable, and the brand continuously works to improve its environmental impact. Once quality control is complete, the cans are grouped into multi-packs or loaded into larger cases for shipment. The fully packaged Red Bull cans are stacked onto pallets, shrink-wrapped for stability, and transported via conveyor belts to warehouse storage areas. From here, they are loaded onto trucks and distributed to retailers worldwide, ensuring Red Bull remains available in over 170 countries. Red Bull's distribution network is a well-oiled machine. Warehouses across the globe keep inventory moving swiftly, ensuring shelves are always stocked. From vending machines in Tokyo to convenience stores in New York, every can of Red Bull follows a meticulously planned route from factory to consumer. Beyond production, Red Bull's influence extends far beyond just being a beverage. The company has built an empire around extreme sports, sponsoring high-adrenaline events in motocross, Formula One racing, snowboarding, and even space jumps. This marketing strategy has made Red Bull synonymous with adventure, pushing the limits of human endurance and innovation. But what makes Red Bull stand out is not just the drink itself, but its precision-engineered production process. The brand operates multiple production plants worldwide, each fine-tuned to produce millions of cans per day. Cutting-edge robotics ensure that every step, from ingredient blending to packaging, runs seamlessly. Advanced AI-driven quality control systems continuously monitor production, instantly flagging any anomalies and maintaining the brand's commitment to excellence. Even the logistics of Red Bull's supply chain are meticulously designed. The company employs a just-in-time manufacturing approach, ensuring minimal waste and maximum efficiency. From the moment raw materials arrive at the factory to the second a can lands in a store, every phase is optimized for speed and sustainability. And then there's Red Bull's marketing, a powerhouse in its own right. The company doesn't just sell an energy drink, it sells a lifestyle. Red Bull Media House produces high-octane content featuring world-class athletes, breathtaking stunts, and record-breaking feats. Whether it's sponsoring extreme sports events or creating viral video campaigns, Red Bull has mastered the art of brand storytelling, ensuring that every sip of the drink is associated with thrill-seeking energy and limitless possibilities. It all starts with tiny tobacco seeds, which are so small that thousands fit into a single gram. These seeds are sown in controlled environments, usually greenhouses, where they are nurtured and carefully monitored. Once the seedlings reach a sufficient size, they are transplanted into open fields, where they are given ample space to grow. Farmers ensure that the plants receive the optimal amount of sunlight and water, while also protecting them from pests and diseases. This stage is labor-intensive, as the plants require constant attention to maintain their health and quality. Regular weeding, fertilization, and soil management are essential to encourage robust growth. After about 4 to 6 months, the plants mature, their large, vibrant leaves beginning to show hints of yellow. This color change signals that the leaves are reaching the ideal stage for harvest. Timing is crucial. The leaves must be neither too green nor too dry. Experienced farmers can gauge the perfect moment just by the texture and color of the leaves. Harvesting is a precise process. In some regions, skilled workers carefully hand-pick the leaves to avoid damaging them, while in larger operations, automated cutting machines are used to speed up the process. Only the highest quality leaves are selected, as they will directly impact the final product's flavor and smoothness. The harvested leaves are bundled and transported to curing facilities, where they are prepared for the next stage of production, curing and fermentation. Freshly harvested tobacco leaves are far from ready for cigarette production. To unlock their characteristic flavor and aroma, they must undergo a crucial process known as curing. This involves drying the leaves under controlled conditions to remove excess moisture while preserving the natural oils and compounds that contribute to their taste. There are several curing methods, each chosen based on the type of tobacco and the desired flavor profile. Air curing. The leaves are hung in ventilated barns and allowed to dry naturally over several weeks. This method produces a light, mellow flavor, often used in pipe and chewing tobacco. Flue curing. One of the most popular methods for cigarette tobacco, where warm air circulates through curing barns, gradually drying the leaves over 7 to 10 days. This results in a bright, mild tobacco flavor, commonly associated with cigarettes. Sun curing. The leaves are spread out under direct sunlight, where they dry quickly, developing a sweeter, milder taste. This technique is common in Mediterranean regions. Fire curing. Wood fires are set in barns to generate smoke, which infuses the tobacco with a rich, smoky flavor. This method is often used for stronger, more robust tobacco blends. Once cured, the tobacco enters the fermentation phase, a slow aging process that refines its taste, removes harshness, and enhances smoothness. During fermentation, the leaves are carefully stacked and covered, allowing natural enzymes to break down undesirable compounds. This aging process can take several months and is crucial for developing the rich, complex flavors associated with premium cigarettes. Processing the tobacco. At the factory, large bundles of cured tobacco arrive for further processing. The first step is sorting, where skilled workers and automated systems categorize the leaves based on quality, size, and color. This sorting ensures that only the finest leaves are reserved for premium blends, while lower-grade leaves may be used for budget brands or flavored cigarettes. Next, the leaves undergo conditioning, where they are moistened and gently heated to make them pliable for further processing. This step is crucial, as overly dry leaves can crumble during the next stage. Stripping. Stripping involves removing the central veins from the leaves, as these tough, fibrous parts can negatively affect the smoking experience. The stripped tobacco is then shredded into fine, even strips, ensuring consistency throughout the blend. Cigarette manufacturers carefully mix different types of tobacco to create unique flavor profiles, maintaining a consistent taste across every batch. Flavoring agents and additives may also be incorporated at this stage to enhance aroma or smoothness. Rolling and cutting. With the tobacco prepared, it's time to roll and cut the cigarettes. The shredded tobacco moves to high-speed rolling machines that can produce up to 20,000 cigarettes per minute. The process is an impressive display of precision and efficiency. A continuous sheet of thin cigarette paper rolls out, forming a long, unbroken tube. A precise amount of shredded tobacco is evenly distributed along the paper, ensuring uniform filling. The paper is tightly rolled around the tobacco, creating a long, cylindrical rod. The rod is cut into individual cigarette lengths, each stick uniform in size and density. Throughout this process, automated sensors monitor every step, detecting any inconsistencies in filling or rolling. Defective cigarettes are immediately removed from the line to maintain quality standards. Adding the filter. The next step involves attaching filters to the freshly rolled cigarettes. Filters are made from cellulose acetate, a fibrous plastic material designed to reduce the harshness of smoke. The filters are cut to length and wrapped in tipping paper, which often includes ventilation holes for a smoother draw. The filter tips are then securely bonded to the cigarette rods using a special adhesive. Advanced machines ensure that the alignment and attachment are flawless, as any irregularity can affect the smoking experience. Once assembled, the finished cigarettes undergo rigorous quality control. Automated scanners check for size accuracy, proper tobacco filling, and any visual defects. Cigarettes that don't meet the strict criteria are discarded. Packaging and distribution. Once quality control is complete, the cigarettes are bundled into packs of 20, which are then wrapped in foil to preserve freshness and sealed in branded cardboard packaging. An additional layer of cellophane is applied to protect against moisture. The packs are arranged into cartons, which are then stacked onto pallets for shipping. Massive logistics operations coordinate the movement of these products from factories to distribution centers worldwide. Whether transported by truck, ship, or plane, every shipment is carefully tracked to ensure it reaches retail outlets promptly. Through an efficient distribution network, cigarette manufacturers ensure that their products are always available on store shelves, in vending machines, and at various points of sale across the globe. If you're amazed by the engineering and precision behind cigarette production, hit that like button. Want to see more behind-the-scenes factory tours? Subscribe to our channel so you never miss out on the next deep dive into the world of manufacturing. Sustainability and innovation. Despite the declining number of smokers in many countries, cigarette manufacturers continue to adapt by implementing new technologies. Some companies are developing biodegradable filters to reduce pollution, while others invest in alternative nicotine products like heated tobacco and e-cigarettes. Efforts are also being made to reduce the environmental impact of cigarette production. Many factories have switched to renewable energy sources, optimized water usage, and adopted recycling programs to manage waste more efficiently.
The journey of an EV battery begins deep within the earth, where essential raw materials like lithium, cobalt, nickel, and graphite are extracted. These materials are the lifeblood of EV batteries, with lithium taking center stage as the key ingredient in lithium-ion batteries. But where do these crucial elements come from? Lithium. Lithium is primarily extracted from two sources: salt flats and hard rock mines. In places like South America's Lithium Triangle, spanning Argentina, Bolivia, and Chile, the extraction process involves pumping lithium-rich brine water from underground reservoirs to the surface. This brine is spread across massive evaporation ponds, where the sun does the work of slowly evaporating the water, leaving behind concentrated lithium salts. This process can take anywhere from 12 to 18 months to complete. Nickel, cobalt, and manganese. These metals are typically mined from underground deposits found in places like the Democratic Republic of Congo for cobalt, Russia, Indonesia, and Canada. Miners extract large quantities of ore, which is then crushed and processed to separate and purify the metals. Nickel is particularly valuable for EV batteries because it boosts energy density, allowing cars to travel longer distances on a single charge. Once the raw materials are extracted, they undergo rigorous purification processes. This step is critical since even trace amounts of impurities can degrade the battery's performance, reduce its lifespan, or increase the risk of malfunction. The purified materials are then shipped to specialized processing plants, ready for the next crucial stage: cathode and anode production. Step 2. Cathode and anode production. At the heart of every EV battery lies the cathode and anode, the two main electrodes that store and release electrical energy. Think of them as the positive and negative terminals of a battery. Cathode production. The cathode is crafted from a precisely engineered mixture of lithium, cobalt, nickel, and manganese. These materials are blended into a fine powder and then mixed with a special binder. The resulting slurry is coated onto aluminum foil, which serves as the conductor for the electric charge. Anode production. The anode, on the other hand, is primarily made of graphite. Similar to the cathode process, the graphite powder is mixed with a binder and coated onto a thin sheet of copper foil. Graphite's structure allows it to store lithium ions during charging, making it a vital component in battery performance. Once coated, both cathode and anode foils are dried, pressed, and cut into precise shapes. These sheets will later be layered together to form the battery's core. Any imperfections in this process, such as uneven coating or air bubbles, can compromise the battery's stability and efficiency. This step requires precision on a microscopic level. Step 3. Cell assembly. With the cathode and anode materials ready, it's time for the most complex and exciting stage: assembling the battery cells. This process is often compared to building a high-tech sandwich, with each layer playing a crucial role. First, a porous separator, made from a thin, flexible membrane, is inserted between the cathode and anode to prevent them from touching. This separator allows lithium ions to flow between the two sides while preventing short circuits. The sandwich is then either wound into a spiral, for cylindrical cells, or stacked flat, for prismatic and pouch cells. Cylindrical cells resemble a tightly wound jelly roll, while pouch and prismatic cells are arranged like flat stacks. This structural difference influences how the cells are used in EV battery packs. Once the assembly is complete, the cells are encased in protective shells. Cylindrical cells are placed in metal canisters, while pouch cells are sealed in flexible, vacuum-sealed pouches. These airtight seals are crucial for keeping moisture and oxygen out, as even a small amount of contamination can affect battery performance and longevity. Step 4. Electrolyte filling. At this stage, the battery cells are still dry and cannot conduct electricity. To activate them, manufacturers inject an electrolyte, a special liquid or gel, into each cell. The electrolyte acts as the bridge that allows lithium ions to move between the anode and cathode during charging and discharging. This process is conducted in a highly controlled, moisture-free environment to prevent contamination. The cells are then soaked to ensure the electrolyte is fully absorbed into the separator, anode, and cathode materials. After soaking, the cells are sealed again to create an airtight environment, ensuring no moisture or oxygen enters. The cells are left to age for a period, allowing the electrolyte to fully integrate with the other components and stabilize the battery's chemical structure. Step 5. Formation and aging. Now it's time to wake up the battery. Unlike flipping a switch, activating a battery is a slow, deliberate process known as formation. During formation, each cell is charged and discharged several times to trigger and stabilize the chemical reactions inside. This process establishes the battery's final capacity, stability, and lifespan. If any cell fails to meet performance standards, it's either reworked or discarded. This step can take several weeks to complete. While aging, each cell is closely monitored. Advanced AI-driven testing systems scan for voltage fluctuations, temperature changes, and capacity issues. Any defective cells are identified and removed to ensure only the highest quality cells continue to the next stage. If you're enjoying the video, then kindly like, share, and subscribe to our channel. Step 6. Battery pack assembly. While individual battery cells are powerful on their own, they're not enough to power an electric vehicle. So, manufacturers combine hundreds, sometimes thousands of these cells to create a battery pack. The cells are placed into specially designed modules. These modules are like mini batteries that are grouped together and connected with high-voltage wiring, sensors, and cooling systems. Cooling is essential to prevent the pack from overheating during use. Each module is tested, and once verified, they're connected together to create the full battery pack. The pack is then placed inside a strong metal or composite casing to protect it from impacts, debris, and extreme weather. This protective shell is crucial for safety, as the pack is often placed beneath the vehicle's floor. Step 7. Quality control and testing. Before an EV battery leaves the factory, it's subjected to an extensive series of quality control tests. Each battery's voltage, capacity, and internal structure are examined. Advanced X-ray machines, ultrasonic scanners, and thermal imaging are used to detect microscopic flaws that could compromise the battery's integrity. The battery pack is also exposed to extreme conditions, such as heat, cold, and vibration, to simulate the harsh environments it will face in an EV. If a battery fails any of these tests, it's either scrapped or sent for rework. Step 8. Final integration into EVs. The final step is to install the battery pack into the electric vehicle. The pack is lifted into the vehicle's chassis and securely bolted into place. Sensors and control units are connected to ensure the battery's health can be monitored in real time. Once installed, the entire vehicle is tested to ensure the battery system works perfectly. Charging, discharging, and energy efficiency are all verified before the EV rolls off the production line and into your driveway. The journey of a battery. From the depths of the earth to the assembly line of a state-of-the-art factory, the process of making an EV battery is one of the most complex manufacturing feats in the world. Each step, from mining raw materials to charging the first cell, is part of a larger mission to create cleaner, more efficient transportation for our future. Designing and modeling. Before any steel is cut or machinery is built, it all starts on paper, or more accurately, on powerful 3D modeling software. Architects, engineers, and designers work together to create a vision for the ship. This includes every detail, from the structural layout to the placement of swimming pools, theaters, and cabins. The blueprints aren't just for aesthetics. They also ensure the ship meets strict safety regulations. Each deck is analyzed to accommodate weight distribution, stability in rough seas, and emergency evacuation protocols. Designing a cruise ship is a balancing act, blending function and luxury with the ship's primary purpose, to provide an unforgettable experience for passengers. Did you know some of the world's largest cruise ships have more than 20 decks, over 2,000 cabins, and can accommodate up to 8,000 people, including passengers and crew? That's a small city on the water. Step 2. Cutting and shaping the steel. Once the design is finalized, it's time to bring the ship to life. The process begins in the steel yard. Giant sheets of steel, each weighing several tons, are delivered to the shipyard. These are the building blocks of the ship, forming its frame and hull. Advanced laser and plasma cutting machines are used to slice through the steel with incredible precision. These machines can work for hours, cutting sheets into complex shapes and sizes needed for the ship's structure. But it's not just about cutting. The steel must also be shaped and bent into curves that match the ship's hull design. Specialized machines and hydraulic presses are used to bend the steel into the exact contours required. This is no small feat, considering the sheer size and thickness of the materials involved. Every piece of steel is inspected multiple times to ensure it meets quality standards. Even the smallest imperfection could cause issues later. Step 3. Assembling the blocks. Here's where the magic of modern shipbuilding comes in. Instead of building the ship from the ground up, it's constructed in sections known as blocks. Each block is essentially a fully functional module, complete with pre-installed piping, wiring, and ventilation systems. Think of it like assembling a giant Lego set, but each brick weighs hundreds of tons. These blocks can range from small sections to entire segments of the hull, complete with multiple decks. The blocks are built in separate workshops, which allows different teams to work on multiple parts of the ship simultaneously. This parallel process speeds up construction significantly. Once the blocks are ready, they are transported to the assembly area using enormous cranes capable of lifting hundreds of tons in one go. Watching these cranes in action is like watching a scene from a sci-fi movie. Step 4. Keel laying, the ship's berth. The keel is the backbone of the ship, running from bow to stern. Once it's laid, it marks the official start of the ship's assembly. This is such an important milestone that it's often celebrated with a ceremony. A coin or token is placed under the keel for good luck, a tradition that dates back centuries. With the keel in place, the ship begins to take shape. Workers start welding the blocks together, creating the basic structure of the hull. This process takes months and involves thousands of skilled laborers and automated welding machines working around the clock. The welding sparks flying across the shipyard are a sight to behold, a dazzling reminder of the hard work and precision involved. Step 5. Completing the hull. As the blocks are joined, the ship begins to resemble the giant vessel it will soon become. The hull is the ship's outer shell, and it must be both incredibly strong and perfectly watertight. The hull is also painted with specialized marine coatings to protect it from the harsh ocean environment. These coatings prevent rust and discourage marine organisms like barnacles from attaching to the surface. It's a painstaking process, requiring thousands of gallons of paint to cover the massive structure. Step 6. Outfitting the interiors. Once the hull is complete, it's time to transform the steel structure into a luxury cruise ship. The outfitting stage is where the magic happens. Teams of workers install everything from staircases and chandeliers to water slides and wave pools. Cabins are outfitted with beds, furniture, and entertainment systems. Restaurants and theaters are constructed, each one uniquely themed to enhance the passenger experience. One fascinating part of this process is how modular the interiors are. Prefabricated cabin units are often built off-site, fully furnished, and then installed into the ship like puzzle pieces. This not only saves time, but also ensures a consistent level of quality. Step 7. Installing engines and propulsion. No ship can move without a heart, and for a cruise ship, that heart is its propulsion system. Most modern cruise ships use advanced azimuth thrusters, which allow the ship to move in any direction, even sideways. These thrusters are powered by massive engines that can generate tens of thousands of horsepower. The engines are designed to be as efficient and environmentally friendly as possible. Many newer ships use LNG, liquefied natural gas, which burns cleaner than traditional fuels. Some even incorporate hybrid systems with battery storage for reduced emissions. Step 8. The nerve center. The bridge is where the ship's operations are controlled. It's equipped with state-of-the-art navigation systems, radar, and communication equipment. The captain and crew rely on these tools to safely guide the ship through various weather conditions and tight ports. What's fascinating is how automated many of these systems are. Modern cruise ships can practically steer themselves using advanced autopilot systems, though the crew is always on hand to ensure everything runs smoothly. Step 9. Testing. Before the ship can welcome passengers, it must prove itself at sea. Sea trials are rigorous tests conducted in open water to evaluate the ship's performance, safety systems, and seaworthiness. During these trials, the ship is pushed to its limits. Engineers test the engines, steering systems, lifeboats, and even the ship's ability to handle emergency situations. It's the ultimate quality control check before the ship is handed over to its owners. Step 10. The finishing touches. After passing sea trials, the ship returns to the shipyard for final touches. This includes stocking the kitchens with food, filling the swimming pools, and training the crew. Every detail is checked and double-checked to ensure the ship is ready for its maiden voyage. The ship's name is revealed during a grand christening ceremony, often attended by dignitaries and celebrities. A bottle of champagne is smashed against the hull, a tradition believed to bring good luck. The journey begins, and just like that, the ship is ready to set sail. What began as sheets of steel and a dream has transformed into a floating city, ready to carry passengers to exotic destinations around the globe. Behind every grand staircase, every gourmet meal, and every sunset view is the hard work and dedication of thousands of people. Next time you see a cruise ship on the horizon, remember the incredible journey it took to get there, a testament to human ingenuity and teamwork. If you enjoyed this deep dive into shipbuilding, don't forget to like, subscribe, and hit that notification bell. We'll bring you more behind-the-scenes looks at how the world's most incredible machines are made.